In this video, I'm going to go over finding the volume of a bunch of these different figures. I'm going to skip a few on these notes that are kind of more straightforward and try to do kind of a variety of questions. So again, if you have questions about ones that I didn't go over in the video, please check out the key on Canvas and then come see us for any questions in office hours. Okay, so I'm actually going to start by looking at number 3. All right, this one says to find the exact volume of the solid below. And when I take a look at this, I notice we have a cylinder and then we have a hemisphere or half of a sphere on top. So I'm going to find the volume of the cylinder as well as the volume of the hemisphere or half of a sphere. All right, and then kind of put those together with addition to find the volume of this solid. All right, so my formula for the volume of a cylinder is pi r squared h. The formula for the volume of half of a sphere is I'm going to do 1/2 and then times the 4/3 pi r cubed. All right, because I do need to cut it in half. All right, so going with the cylinder, we have the radius is going to be half of that 4 centimeters, which is 2, and the height is going to be 2.5. And then for my hemisphere, I'm going to have 4/3 times pi times the radius of 2 cubed. All right, so for my volume for my cylinder, that is going to be 4 when you square 2. 2.5 times 4 is 10, so this is going to be 10 pi cubic centimeters. And then for the hemisphere, that's going to be 2 cubed, which is 8. 8 times 1/2, that's 4. So 4 times 4/3 is going to be 16 pi over 3 cubic centimeters. Okay, so to find the volume of this solid below, you're going to add these together to get 10 pi plus 16 pi over 3 cubic centimeters. If you wanted to get a common denominator, you could. Rewriting 10 pi with a denominator of 3 would be 30 pi over 3 plus 16 pi over 3. So you could also write 46 pi over 3 cubic centimeters. So that is it for number 3. Okay, let's go to number 4. All right, so I chose this one because you can see that we have some chunks kind of taken out of what would be a more straightforward problem with a prism. So what I'm going to first do in this one is I'm going to find the volume as if those chunks were not taken out. So find the volume of the prism. And then you can kind of notice if I put each of those chunks together, that would be a cylinder. So once I find that volume, I can subtract it out from the volume of my prism, which would give me the volume of the solid below. So the volume formula for a prism is the area of the base, right, that big B, times the height. The volume formula for a cylinder is pi r squared h. So I'm going to choose my base to be this one, which means that the area is going to be 10 times 3 or 30, and then the height is going to be that 8 inches. So my volume for the prism is going to be 240 cubic inches. For the cylinder, I'm going to do pi, the radius is going to be half of that diameter of 8 to be 4 inches squared times the height, which is going to be 3 inches. So I'm going to square that 4 to get 16. 16 times 3 is 48, so 48 pi cubic inches. Again, this is a little bit different than number 3. Right, in number 3, we added them together. In this case, we're going to subtract the volume of the prism. So this is the volume for the figure below, or the solid. I'm going to take the volume of the prism and subtract the volume of the cylinder. All right, and because it wants an exact answer, leaving it with a simplified radical or pi, I'm just going to leave it like this to write 240 minus 48 pi cubic inches. Okay, that's number 4. Let's move on and do number 5. Now, number 5 gives us a square pyramid, all right, and it says the slant height is 3 times the square root of 14. So I'm going to show you here, right, that slant height is 3 times the square root of 14. It also says the base edge is 12, so all of these are going to be 12, right, because it is a square. Now, if you look kind of inside here, we can see this kind of dotted line here for that base, right? That is going to be half, so that's going to be 6, and we have created a right triangle kind of inside that pyramid. All right, the reason this is important is because to find the volume for a square pyramid, it's going to be 1/3 times the area of the base times the height. So we do need to find that height, right? This h will allow us to figure out the volume. So we'll kind of do it over here. So I'm going to use Pythagorean theorem since I have 2 out of 3 side lengths for a right triangle. And I'm going to choose h squared plus 6 squared equals to my hypotenuse, which is 3 times root 14 squared. So that's going to be h squared plus 36 equals, remember you square the 3, that gives you 9. The square root of 14 squared is just 14. So 14 times 9 is going to be 126. Subtract the 36, you get 90. So h equals the square root of 90. There is a perfect square in 90, right? 9 times 10. So this reduces to 3 root 10. Okay, so we have found the height. Now we can go back and find the volume of this by doing the area of the base. Remember, as it said in the problem, the base is a square. So my area formula is just going to be that side squared, so 12 squared, times the height, which is 3 times the square root of 10. When I do this, my 1/3 right here and my 3 are going to make 1. So 12 squared is 144 times the square root of 10. And that's going to be my volume. So I put it as units cubed. Okay, that's number 5. Again, I'm trying to give you kind of a variety here of different type of figures. Okay, let's go to one more. All right, this one right here, if you take a look, is a prism. And if you look at the base, it has 1, 2, 3, 4, 5, 6 sides. So it's a hexagonal prism. All right, to find the volume for this, we are going to do the area of the base times the height. So I need to first find the area of that base. So I'm going to actually redraw this hexagon a little bit larger so I can do some work that we've done in previous videos, previous lessons, to help us figure out this volume. All right, so I'm going to draw my apothem. All right, I'm going to draw my radius. And hopefully you know by now, if you don't, you can always use that sum of the interior angles formula that we've used in the past. The angles here on a regular hexagon are all 120 degrees. So when I drew that radius, it's going to split it into 60 degrees there. So then this one up there is 30 degrees. All right. Now it does tell us in the problem that the base, if you look at this value here, right, the 8 millimeters is going to go here. So that means if I split it in half, that's going to be a 4. And we have a 30, 60, 90 right triangle, so I can fill in the rest of these. All right. They've given me the side opposite the 30-degree angle, so the small side or the small leg. So the large leg is going to be 4 times the square root of 3, and the hypotenuse is going to be double that small leg to be 8. Now, when I do my formula for the area of this base, right, I'm just going to use 1/2 times the apothem times the perimeter. So I'm going to multiply 1/2 times 4 times the square root of 3 times the perimeter, which is, we have 8, there's 6 sides, so that's going to be 48. So the area of the base, I'm going to do half of 4, which is 2. 2 times 48 is 96 times the square root of 3 millimeters squared. So that right there is the area of the base. Now we can move back over to our volume formula, and we can figure out the volume of this solid. So volume equals 96 times the square root of 3, right? That's the area of the base. The height, right? The height is right here, which is 12 millimeters. So if I multiply all that together, that's going to give me 1,152 times the square root of 3 millimeters cubed. All right? So that is how you find the volume for this hexagonal or hexagonal prism. Again, I skipped a couple, as you saw, too early. There's one after this. So check out that key and then come see us with any questions. All right? Good luck.